Okay, so we need to quickly move on because I need to get to the point about talking about the capacitors. Because you'll recall in the last video I held up these two capacitors, something like this, and I said we need these as well. And we do. Capacitors work as buffers, stabilizers. They're like water towers. If I want to have, I can have a small pump slowly filling up a water tower, and a water tower, of course, is held up high in the air and gravity's pulling it down. And as long as there's some value of water, some amount of water within the water tower, it holds a really nice constant pressure. And it's able to take variances of output as thousands of people take the shower at the same time, and then fill back up again as the demand goes down. Now, there's lots of values. There's lots of sizes of water towers. The smaller the water tower, the smaller the capacitor, the kind of quicker it responds, the smoother it can actually be. The larger ones will handle greater changes, greater differences. Okay, and if we look online, if you go ahead and put in, for example, what did I put in my search engine here? 7805 circuit Arduino, figuring a lot of people are building circuits with Arduinos and 7805s like you are. And let's scroll down and choose one. Okay, we can see here's our 7805 or 78S05, depending on which one you have. Typically, applications have fairly small values of capacitors. This on the input side, where we have our battery supply, tends to be larger than the output supply. In this case, the recommended one is a 0.33 microfarad and an output of a 0.1 microfarad. Both of these capacitors essentially stabilize the input and the output, so that if we have spikes here or here, they get buffered by the capacitor, so we don't lose. It doesn't cut out because it lost its supply of electrons, or in the water tower analogy, it lost its supply of water. And also on the output side, it helps regulate the input and output of electrons or water. If we scroll on, you can see this particular one uses different values here. This one's up to 220 microfarad and 47 microfarad. And when you sit down and kind of punch it all out and play with it, generally it's been my experience that the recommended capacitor voltage is what works. Okay, we're going to be dealing with DC motors. DC motors have stalls, they have all kinds of high current draw. These aren't even great DC motors we're going to be playing with, or for essentially economy toy DC motors. And I'm going to bias it for a rather large value on the input side. Okay, on the input side where they're using 0.33, I'm actually going to go, you can change this if you want it, and I'll explain a little bit. I'm going to actually go with 100 and a 22. Okay, because it seems to have worked for me. 110 might be, with a tenfold difference, might be kind of more typically preferred. But I've been using 122s, 100 microfarad and 22 microfarad for quite a while, and it seems to be fine. If you find that your circuit's cutting out as the motors are turning on and off, you might say, well, maybe I need a little bigger capacitor here to stabilize this. If it's been flawless and working well, you could probably reduce these values to give it a little bit more smoother reaction. But at any rate, I'm going to grab a 100 and a 22, which means I need my glasses. Okay. So in my case, in this particular example, if you look carefully at it, capacitor, you'll see that the ones that I'm providing, at least, there is a positive and a negative. Generally speaking, there's a large gray band. So, let me get this thing out of the way so I can see what you're seeing. Okay. There's a large gray band that designates the negative side. Okay, so this one's a 100 microfarad. I'm going to set that there so I don't lose it. And here is a 22 microfarad. And once again, it's got a gray band which designates the negative side. I'm going to cut these off like this. Okay, a little bit, about like that. Okay, you know, maybe the length of your little finger on both of these, because what we're going to do is we're going to put these into the buses. Like that. Okay, so recall quickly again, we'll pop back up. The larger value goes on the input side. It's preferred to have it as close as practical to the actual 7805 voltage regulator. So I'm going to take this 100 microfarad capacitor. I'm going to carefully orient myself so I see which side is negative. And I'm going to insert this, okay, over here. I should zoom in a little bit so we can actually kind of see what's going on here. Okay, I'm going to insert this into the input side. Remember, this bus is hooked directly to my batteries. Okay, this is my supply side, and I have the ground. Oh my goodness gracious, did you see that? I hate making mistakes like that, but it's good to see me do it. Okay, you'll see the ground needs to be on the ground side. Okay, and if it doesn't work here in a second, we'll know that I fried it and I need to put another one in. Okay, let's look carefully here. I'm not going to make that mistake again. The ground needs to be on the blue side, not the red side. Okay, and I'm going to insert this particular capacitor. Let's move this up a bit. And I'm going to carefully make sure that I do this correctly. Okay, so my 22 microfarad capacitor is over here on the output side, and my 100 microfarad is on the input side, and the ground stripe is closest to the ground bus, and the ground stripe is closest to the ground bus. Okay, so now I have my stabilizers built in. Let's go ahead and make these motors move again. I'm going to pull out this jumper. Let's zoom out so we can see the whole thing. Plug in my USB and load up our motors. Hopefully I didn't burn anything out. If it does, you can usually smell it. You'll get the smell of the magic smoke. Magic smoke is the material that makes electronics go, and if you let it out of any electronics, they stop working. Okay, it's working great. Let's pull this out and let's run it on autonomously. I'm gonna put my glasses back on and use my handy dandy jumper across. Okay. So there you go. Now we have a stabilized and protected circuit running on batteries, disconnected from the computer. So I believe the next video will be how to assemble your robot chassis, and we're about ready to make a robot dance. So I will see you soon.